It started with a star just like our sun, quietly orbiting the center of its galaxy, until one day it strayed too close. That's when the black hole woke up. Astronomers call this kind of cosmic violence a tidal disruption event. It's one of the most terrifying and fascinating displays in the known universe, when a black hole rips a star apart and feasts on its remains. But until recently, we had only glimpses, dim X-ray flashes, faint ultraviolet light. The afterglow, not the act. That changed with the James Webb Space Telescope. On July 12, 2025, NASA confirmed that James Webb had captured the most detailed view ever of a star being shredded by a black hole in the galaxy NGC 7392 about 137 million light-years away. And what it saw was jaw-dropping. James Webb's infrared instruments picked up the heat signature of shredded debris, the outer, cooler parts of the star forming a disk around the black hole known as an accretion disk. The debris heated to extreme temperatures, with the outer regions glowing in infrared, making them detectable by James Webb. The accretion disk wasn't flat and stable like a record. It was chaotic, flared, dense, and turbulent. The structure of the accretion disk helped scientists measure the rate at which matter was falling in, roughly the mass of Jupiter every few days during the event's peak. Even more astonishing, James Webb's precision revealed the shape of the flare itself, showing how the light changed over time, indicating when and where the debris became hottest, and how it cooled as the black hole slowly devoured it. And right at the heart of it all, the event horizon. That's the invisible boundary around a black hole where gravity is so strong not even light can escape. Once the star's material crossed that point, it was gone. Forever. Now you might be wondering, how do we even see this happening? Well, James Webb didn't see the black hole itself. Black holes are invisible, but it detected the infrared radiation, the heat, coming off the superheated debris before it vanished. And when scientists combined this data with earlier X-ray readings from NASA's Chandra Observatory, they were able to map the process in unprecedented detail. One researcher called it a front-row seat to one of the most extreme events in the universe. And for scientists, this isn't just about one star. These observations are clues, evidence, that helps answer big questions. How do supermassive black holes grow? How often do they feed? And what happens to the material they don't swallow? The findings from NGC 7392 support models that say black holes don't grow slowly. They feast in bursts. And that could explain how some supermassive black holes reached billions of solar masses just a few 100 million years after the Big Bang. Let's take a moment to absorb that. We're watching the death of a star. Not in a simulation, not on a whiteboard, but in real time through the lens of a telescope orbiting 1 million miles from Earth. The James Webb Space Telescope is not just capturing pretty pictures, it's rewriting what we know about physics, time, gravity, and death. Because somewhere out there in the darkness, another star is drifting too close, and James Webb will be watching. What else might James Webb reveal about the universe's darkest corners? Stay curious and keep looking up.